guys. All right, so if we have 10 moles of C2H2, we want to find moles of oxygen gas. Well, right now, if we look at our ratio, right now, if we have 2 moles of C2H2, we can create 5 moles of O2, or we also need 5 moles of O2. So what this is asking is if we have 10 moles of this, how many moles of O2 will we make? And I think most of you can probably do that in your head. But here's where I'm coming with this. You're going to start with 10 mole of C2H2. And this is where we're going to use our conversion factor from our balanced chemical equation. So we need 2 moles of C2H2. And we also need 5 moles of O2. Moles of C2H2 cancel. So 10 times 5 divided by 2 is going to give us 25, right? Is that right? 25? Yep. So, and you could probably have done this in your head, right? If you have 2 moles and you need 5 moles, well, if you have 10, right, that's the same as 25. 2 to 5 is the same as 10 to 25 as a ratio. Okay? So 2 to 5 is the same as 10 to 25. They're the same. Okay? So let's do this one. Here, we want to find moles of oxygen gas. And we have 3.6 moles of C2H2. So again, we start with 3.6 moles of C2H2. This one is not so fun to do in your head because it's 3.6 moles. So we don't really know, right? We don't know what that ratio would be without doing like this math maybe. So 2 moles of C2H2 is on the bottom, and 5 moles of O2 is on top. So 3.6 times 5 divided by 2. I forgot my calculator over here.
3.6 times 5.
3.6 times 5 times 5 divided by 2. 9? Yeah. 9 moles of O2. So the ratio 3.6 to 9 is the same as 2 to 5, is the same as 10 to 25. Okay, let's do a different one. Let's do number 2. Number 2, we have 4 moles of aluminum and 3 moles of oxygen, O2, and that's going to produce aluminum oxide. So it says how many moles of oxygen are required to completely react with 9 moles of aluminum. So we're going to start with the 9 moles of aluminum. And here we want to go from aluminum to oxygen. So we need 4 moles of aluminum on the bottom. And we need 3 moles of O2 on top. So 9 times 3 divided by 4, 6.75. Do you want to try these 2 on your own?
Yes.
Okay, try these on your own, showing your work. You have 14.8 moles of aluminum. How many moles of Al2O3 will you have? All right, I'm going to start doing them. See if you're right. We're going to start with 14.8 moles of aluminum. And we're trying to get to moles of aluminum oxide. So we have a 4 moles of aluminum, and we have 2 moles of aluminum oxide. So because we have moles of aluminum up top, we need 4 moles of Al on the bottom and 2 moles of Al2O3 on the top. So we're going to do 14.8 times 2 divided by 4, and you get 7.4 moles of Al2O3. For this one, you always start with the number 0.78 mole of O2. We have 3 moles of O2 in our ratio to 2 moles of Al2O3. Zero 0.52 moles of Al2O3. I think we'll stop there.